Hey, hi everyone. Today I'm going to explain a exercise about projectile motion in two dimensions. The first things that you need to remember is when you talk about horizontal displacement and vertical displacement. And we are going to use those specific formulas. As you can see here, the yellow ones represent the horizontal displacement and the blue ones represent the vertical displacement. How are we going to identify also in the formulas? Because when you have the x means horizontal displacement or the velocity in the x-axis. And when you have the y represent the velocity and the vertical displacement, or it's a when the object fall down. So another thing, this f means the final displacement in the horizontal part. This means initial displacement, initial velocity in the horizontal displacement, and the time. T means time. And in this one, the F means final velocity, but in the vertical displacement. Initial velocity in the vertical displacement, gravity, which is 9.80 meters per second, and the time. And finally, we have the final velocity to the power of 2 raised to the second, initial velocity raised to the second. This is when you have two velocity. But remember, when you don't have velocity, at the beginning, the velocity it's always 0. Or like the displacement also can be 0. Then you have minus 2 multiplied by the gravity, and the y is the distance, but in the vertical displacement. Could be 50 meters, 10 meters, any quantity, but in the vertical displacement. So knowing those informations, I'm going to explain you this exercise. A ball rolls off a desk at the speed of 3 meters per second. Remember, when you see meters per second refers to velocity or speed, and lands 0.40 seconds later. Second refers to time. And then it's asking you, how far from the base of the desk does the ball land? We in this problem, we had the initial velocity, which is 3 meters per second. We had the time, which is 0.40 seconds later. And we are looking for distance, how far from the base. Imagine that this is your ball, that you have it, and then you have a desk, and then the ball is rolled off through the desk. So as you can see, it's a horizontal displacement. Then in the second part, it's asking you, how high is the desk? When you say how high is the desk, it's asking you for the vertical displacement. So first, we are going to solve the first exercise. In this case, we have initial velocity in x, because remember the ball rolls in the horizontal displacement. And we have the time, and we need to look for the final displacement once the ball finished the roll. So the formula that match with that one is this one, the first one. Why the first one? What is our initial displacement? It's 0. Remember the initial point is 0. Then we have initial velocity in the x-axis. The initial velocity is 3.0 meters per second. And we also have the time, which is 0.40. So now you need to multiply 3 times 0.40, which is 1.2 meters. And then we have to add it with 0, which is 1.2 meters. So once you finish that, you will know that the final displacement once the balls roll is 1.2 meters. Now, having this information, we already answered the first one. Now we need to work with the letter B. How high is the desk? It's asking you for height. In the problem, we only have the velocity and we have the time. Okay, so what you need to do is to identify what information can we use. But remember that we cannot use this velocity because it's in the x. So we only have the value of the time, which is 0.40. And we need to look for the height, or let's say the value for y. This is the value for y. So now what you have to do is to use the formulas that we have for the vertical displacement, or let's say this one or this one. In this case, what you need to identify, what information do we have? And as you can see, the formula that match is the first one. First of all, because maybe to get that y, you need the final velocity or the initial velocity. That's what you need. So in this case, we need to get first the final velocity or the initial velocity. Then once you have that information, you are going to replace to get a value for y, because you need to use both of them in this case. So that's the situation in this kind of problem, that sometimes you need to use both formulas and you have to do 2 or 3 procedures before getting the final answer. Remember, your objective is to get y, but we don't have initial velocity and final velocity, and that's what we're gonna do it now. So look at this. With this information, the initial velocity in the y-axis is going to be 0, right? Then we had the gravity. What is the gravity? The gravity is 9.80 meters per second. But also we had the time, which is 0.40. 0.40. Look. So then you replace those values and you are going to get the answer. In this case, we multiply this 9.80 times 0.40. If you multiply that, you are going to get, let me calculate, 3.92 meters per second, because it's velocity. And 0 minus 3.92 is going to be negative 3.92 meters per second. And that's going to be your velocity, your velocity. So what do we need to do with that? Once you already had the final velocity, remember this one we get because we only had the data of the gravity and the data of the time. That was the reason that we used this one first. But the objective is to get how high, or let's say the value for y. So you already had the final distance. Remember, this f means final, which is 3.92. So we are going to replace. This one becomes to 3.92, but this one is raised to the second, as you can see here in the formula. 3.92 raised to the second. We have the initial velocity, that in this case, we don't have it, because the initial velocity is going to be 0. And then we have the gravity. The gravity, remember, is negative 9.80 because it's a vertical displacement. And finally, you have, sorry, this is 9.80. This is negative 3.82 as you get in the previous step. And with that, you are going to get a value for y. So now, as you can see here, 0 minus 2 times 2.90, the 0 we eliminate basically. And then you are going to get 2 multiplied by 9.80. So once you multiply that, 2 times 9.80 meters per second is going to be negative 19.60 meters per second. And then you need to eliminate. So you are going to divide both sides, and also here, negative 19.60. And finally, you are going to cancel this one. And once you solve this operation, you are going to get a value of negative 0.784 meters, which means the displacement in y. So with this information, you can calculate the final height of the desk. As you can see, to solve the letter B, we need to use both formulas. First, to get the velocity, which is this one, And then with this information that we get, we replace in the second one because our objective or our goal is to identify the value for y. So hope you understand, and any questions, leave in the comments.